All right. So the talk or this webinar is based on my experience of Elixir and Erlang, and I've subtitled it Fundamentally Pragmatic, and we'll get into why that is as we get into things. First, housekeeping. I'm Lars Wikman. My company is Underjord, and you'll find it at underjord.io. With this particular audience, it might not be surprising that I'm an independent software consultant. And what might be more or less common, I'm self-taught, so I have no computer science background. And since at least 3 years now, I work exclusively in Elixir. And before then, I was doing Elixir a bit unprofessionally. So for my own satisfaction. I publish a blog. I write a weekly newsletter about coding in general and sometimes Elixir in specific, and a lot around running a business, actually. And I do weekly live streams where I introduce people to Elixir and do different weird things with it. I'm on 2 podcasts. So Beam Radio, which is centered around the Erlang and Elixir communities, and Regular Programming, which is a regular programming podcast. And you'll find those you can see the URLs here, beamrad.io and regprog.com. So that's me and my background. Now, Elixir and Erlang are both functional programming languages. And I, for the longest time, had these preconceptions of functional programming. So I came from the web. When we got internet back in somewhere in the 90s, we got a small booklet on web design from AlgoNet. And that was the start for me to learn sort of HTML. And this was pre-CSS and pretty much pre-JavaScript. And then I went into Perl, PHP, and Python. So I followed a very, very traditional web path in many ways. And I always, when I heard of functional programming, I saw it as something complicated and mathy. And whenever I saw discussion about it, it would always come up that it was inefficient because immutable data structures and like being able to change data in places can be more efficient. And the languages I heard of were either sort of academic, which is sort of the Haskell side of things, or what I considered arcane or mysterious, like Lisps or many of the other ones. And there was so much theory whenever there was discussion of functional programming. So you have type theory, category theory, and something they insist on calling a lambda calculus. And I didn't know what they were for. And I didn't see a point in sort of exploring functional programming at all. So how did Elixir get to me to the point where I spend all of my day doing Elixir work and being engaged with the Elixir community? So to me, it's important that it showed me very early on that it's a hands-on practical language. It's made to build things. And it had distinct advantages compared to what I was using. So the biggest promise, I think, of Elixir and Erlang is that it allows simple concurrency and parallelism. Yeah, let's go with that. Parallelism. And if you worked in Python like I have, you will know that the concurrency story is ish, and parallelism, I think things have gotten slightly better with async.io, but yeah, the global interpreter lock and all its consequences can really show up sometimes. There are limitations there, and doing anything concurrent is known to be hard, and Elixir does make it quite simple, comparatively simple. Then it actually got me sort of roped in via a project called the Nerves project, which allows you to do IoT development on sort of hobby hardware, so Raspberry Pis and all of that, without needing to go via Raspbian and sort of setting up your own custom stack, but rather boiling it down and letting you use Elixir in a very nice way. And it provided a clear path for web development, which is what I typically do. That's most of my work. And it had the Phoenix web framework right out of the box, and it came with very rich web features, specifically at the time focused on near real time, and it still provides very good near real time features. So that's sort of what brought me in, where the functional programming was almost incidental, but we'll get into more about why this is still a functional language. But let's back up a bit. So how did Elixir get this particular flavor that I'm trying to outline here? So it's a synthesis of two languages, and I think it's important that they are primarily used in industry. And it builds on a foundation of Erlang. And then I think it applied the appeal of Ruby. So let's get into Erlang first, because that's the old one, and that's the foundation. So let's start there. That was born at Ericsson and built to solve particular problems in the telecom space. And particularly at that time, computers were typically single core. And if you needed to add more capacity to a single application, you would be forced to do distributed computing, which was already at the time known to be fairly difficult. So Erlang was an attempt to handle that complexity. And we credit the creation of Erlang to Joe Armstrong, Robert Verding, and Mike Williams. There have been a lot of other people involved over the years, but those are sort of the known crew. I consider it a product of applied computer science. It's very, very hands-on, but doesn't necessarily lack theory. And it's something that people still look very closely at when learning computer science these days. Erlang usually shows up in the curriculum somewhere. And it tackled some very hard problems. So what was Erlang built to do? It was built to do soft real time in the form of low latency and consistently low latency, because it was used in telecom switches, which if you have delays when you're talking to people, that's very noticeable. It was built to do distribution well, so distributed computing, and building applications that can live across multiple computers, multiple physical computers. And it was built to be fault tolerant, because telecom is a business with a lot of requirements for many nines of uptime, and high availability, which feeds into that. Highly available in non-stop operation. Now that becomes interesting, because whenever you need to update, what do you do to maintain your nines? And that steps right into the next part, hot updates. Erlang was designed from the ground up to be able to be updated while it was still running with new code, and handle that gracefully, which is a heck of a feature to pack into a runtime. So it turns out that these combined goals of distributed computing and soft real-time, also mostly by accident, seemingly, set it up perfectly to handle when multi-core came onto the scene. So multi-core concurrency and parallelism are essentially, I could argue it's a subset of distributed computing. At least it has very similar traits, and the way Erlang was built to handle distribution also made it suitable to handle concurrency. But it wasn't built with concurrency in mind in that way. Erlang is about abstractions, in my eyes. So it implements the actor model, and a lot of computer science folks have heard of the actor model, and there are things like akka, and I mean, Ruby is implementing ractors right now, and Swift is getting actors. Everything is getting actors. Erlang has always had actors. It was built to be an actor system. So what are actors? They're independent entities that share nothing. So they share no state, and they communicate via message passing. That's the gist of it. And Erlang's foundational actor primitive is the process, and we'll get into that more later. Erlang is a high-level language. It is not your C equivalent. You can escape out into low-level languages if you really need that kind of performance for particular tasks. It has a highly dynamic nature, so no static types, and not very strict in that sort of compile time way. It runs on a virtual machine known as the Beam, thus Beam Radio, the podcast. And it has a couple of foundational primitives. So there's modules, there's functions, and there's processes. There's more probably in the background, but these are some of the main concerns for you as a developer. And it has a strong focus on runtime concerns. So concurrency, parallelism, and fault tolerance and handling faults, that all happens at runtime. While you can sort of prepare for it at compile time in some languages, you can actually handle a sudden hardware failure at compile time. But you can do something at runtime sometimes. And it comes with a massive, super interesting standard library called the Open Telecom Platform, which has a lot of unusual features. Primarily useful is that it has these fault tolerance abstractions, such as supervision trees that build on top of this actor model to provide resiliency and like powerful ways to build systems that fail gracefully. In my eyes, Erlang is functional by necessity, not sort of by some idea of purity. It didn't have to be, or rather it had to be functional. It didn't necessarily do it just because functional is better. But choosing to make it a functional language with immutability and sort of pure functions, that constrains the problem space. Shared nothing and immutability, no shared state and immutability, limits what problems you actually need to tackle. So by raising the abstraction level and dealing with things at the level of a functional programming language in this way, it allows some very powerful features. So preemptive scheduling, where this is where the soft real time comes from. No process, no function can hog the CPU indefinitely. It will be kicked off of the scheduler and other work can occur, which gives you the chance of forcing reliable, consistent latencies. It allows hot code updates because you can actually know something about what a certain module affects, and you can actually handle the change of the state of the system when you ship new code straight into the running system. It allows massive concurrency and parallelism by not sharing so much information. And it provides these building blocks for creating resilience at runtime. Without immutability, I don't think any of that would be possible in a good way. Now, Elixir was built on Erlang, but by Rubyists. So Elixir compiles to the same virtual machine instruction set as Erlang and runs on the same virtual machine. It was created by Jose Valim, and he came to prominence in the Ruby and Rails space. I'm not saying Ruby on Rails, I'm saying Ruby and Rails, both of them. And many of the Elixir contributors, early Elixir contributors, were also Rubyists. And Ruby and Rails have always been very focused on productive programming and have been the darlings of the sort of startup industry startup world for quite a long time now. So in that way, Ruby and Rails are also tools of industry, not, to my knowledge, academia. So Elixir was built on Erlang and Ruby, tools of industry. All right. So what did we get from Ruby to Elixir? So the focus on productivity definitely showed up. So a heavy focus on developer experience and developer tools. And probably arguably some marketing skills. So Erlang has been powerful forever, like since the 80s, but it has mostly occupied a niche. Elixir is not the biggest language in the world, but it definitely grew the community. Also, Erlang's syntax has often been discussed, and I don't think it's necessarily bad, but it's not particularly familiar if you're coming from Python or Ruby or anything, while Elixir reads very familiarly to those languages. I would say, from what I've understood, I haven't done Ruby particularly, but from what I understand, it's very, very similar from a syntax perspective. And it shipped with it quickly evolved to have a web framework. So it was definitely influenced by Rails in that manner. The language is partly made by having a strong web framework. It uses this powerful Erlang foundation to provide some of the best features for web services I've ever seen. It is arguably the Rails of Elixir. It's definitely the canonical web framework for Elixir, but it has a lot of differences to Rails. And I think having a strong web framework is incredibly important for any language that wants to play in the server space these days. So it has that. So why would you want Elixir? So I consider these common web service requirements. You want to do distributed computing. You typically have your application live across multiple nodes. You very rarely run a single machine these days. You want fault tolerance because it's still about those nines and staying up. It's depending on what you're doing, that's incredibly important or less important, but it's there. Soft real time and low latency is useful in anything. One of my co-hosts on the Beam Radio podcast noted that you really should build your e-commerce on Elixir and Phoenix because it is very good at low latency, and consistently fast e-commerce is a big challenge and directly profitable. So it's good for running high availability, and it lets you deploy without downtime via hot code updates or any of the sort of classical rolling update schemes that people typically use these days. But if these sound familiar, that's because this is what Erlang was built for. And I would say the Beam tackles some of these things very differently than other runtimes and other sort of typical web service strategies, but the capabilities are there and they're foundational. They're built into the runtime. So Erlang, and by by relation Elixir, are very strongly suited to modern service workloads. And I think the people at WhatsApp and the people at Discord who use Erlang and Elixir respectively can probably attest to the kind of ridiculous scale you can run Elixir or Erlang at. So I view it as a practical synthesis. It combines the heritage of two very different languages with shared roots in industry. Quite different industries though. And they are very much about getting things done and making things work that are otherwise very time consuming and or very difficult. And neither spend a lot of time or effort on compile time, correctness, and sort of formality or any of that. So Elixir has taken the Erlang actor model and sort of consistently pressed it further in the service of web tech. And with the relatively recent development of Phoenix Live View, they have pushed that model all the way to the very edge of your server and partway into your client, the web browser. So we have the process, the foundational primitive of concurrency and of the actor model in Erlang. Erlang built on that one to create the gen server. So that's the generic server, which is an actor. It should probably be called an actor. It takes messages, it sends messages, and it has some nice abstractions to make that more convenient to work with. With the Phoenix Web Framework, Elixir brought the Phoenix channel, which sets up an actor to respond to a WebSocket and sort of ties together your client, whether it be a React app or Elm app or Vue or anything, to talk to backend just by message passing. And it can keep tons of these open. The Elixir team early on tested this and pushed it really quite far. And then we have Phoenix Live View, which builds on top of the work with channels and adds declarative templating and an actor model behind it, so that you can define your events, you can listen for your events, and you just update a little bit of state, much like you'll see in any sort of flux pattern or the way React and Vue do things these days, or did. I don't track it that closely. But with Live View, you're passing that information straight across the wire. Everything happens on the server, but you're just sending minimal diffs of like, oh, update a little bit of the UI here. And you never have to write a line of JavaScript, essentially. Or you have to write very little JavaScript to make highly interactive, essentially real-time applications, which is powerful. It's not a solution to everything, but it's very powerful. So I figured I would actually show some of this, not just talk about it. So demo time. I see we had a comment in the chat, and feel free to comment in the chat. I'm happy to talk to you guys while doing this. But yeah, he mentions Walmart running Clojure to survive Black Friday, also decent for big scale. And yeah, actually listened to an interesting Clojure talk, and it seems like Clojure is closer to Erlang and Elixir than I expected it to be. It doesn't quite do the same type of concurrency, from what I understand, but it's definitely an interesting language. Probably not my thing, but I definitely suggest looking at it if it sparks joy. All right, so I set up a little project here where I can show you some of these sort of foundations of the actor model and that progression on into Live View. Just give me a moment. Right, I hope the text is readable enough. Shout at me if that's not the case. So we will start our REPL, and we will look at this, the good processes module. So this contains one function, which is called spawn bunch. It takes a count. It will go through that number of items. It will spawn a process to do some work. And it will pass the PID of the calling process to this worker so that it can send a message back. We will give it a time budget of 1 second, so 1000 milliseconds to complete, because I don't want to wait forever. And Then this is just some bookkeeping to make sure that we enforce that budget across all of the processes we spawn, and just save the execution time, and then give us some stats. And the work function down here, that uses a small function I wrote to use the crypto modules to generate 200,000 random bytes. It's not heavy work, but it's not nothing, and it's CPU bound, which is might turn out relevant. We'll see. So good process has spawn bunch, and let's spawn a decent chunk of processes. So 10,000. Is that a good number? I think 10,000 is a good number. Oh, done. So average millisecond, 5, 5.1. And we had about 990 millisecond left. These counts are not exact, but they're close enough. So one thing about this is that I'm running, we can see here actually, it's running 32 schedulers because it detected that this machine has 32 cores. It's fairly beefy. And it will start one scheduler thread per core, and then the work will be distributed across those, which means it can move pretty fast by default. So the vertical scaling is pretty good. Now, we can actually restrict it to just demonstrate the consequences of this, to tell it, just run one scheduler, please. Now we can see SMP 11, DS 1110. All right. And we run good processes, .spawn bunch. So now we are trying to do 10,000 pieces of work on a single core. Yeah, that takes longer. Takes about half a second. So we can see that there is serious contention for CPU time now with this single core. So let's see what happens if we make a small misimplementation error. This is the very same module, but bad processes. But it does have a bug in it, like the 13th process we spawn. That will just loop back and do more work and more work and more work and more work. So it's an infinite CPU bound loop. That's not great. Typically that's bad. So let's spawn 10,000 processes with this module. So that actually burned our entire timeout budget. So timed out before receiving all replies, expected 10,000, received 9,999. All right. The worst time we're seeing is still pretty close to what it was was for the good processes on a single core. So we started 12 processes, then the 13th one went into a forever CPU bound loop. And then it spawned the remaining ones, and all of them completed except that number 13 probably. And this is what preemptive scheduling gives you. So I can tell you that if you did this with Node.js, you'd have a problem. Now, since Erlang is about the runtime handling of things, let's do some introspection and actually take a look at what happens at runtime. So Observer is a tool built into the Erlang OTP standard library. So we can see here a little bit of information about the runtime. It detected all of our 32 CPUs, but it's only running one scheduler. We can see load charts. These are at runtime. You can also connect this to your production environment if you like, and actually just connect to any node, and you can pull this information from a running system. Memory allocators, applications. So this can give us a map. That's nice. Now, processes is what we want to look at. So here we have a little bit of an outlier. If we're looking for the number of reds, which is reductions, it sort of translates to function calls, and that's how the preemptive scheduler actually knows how to boot something off of the queue and throw it to the back of the line because something has used more reds than it should. So this is a fairly big outlier in reductions. It's at millions, and we can see that it's counting up. So is this our process? Maybe. So let's open the process info for that process. We can see it's Erlang, apply, crypto, not sub to error. I'm not sure, but we can check the stack trace and just go, oh, yeah, this is definitely from our module. This is our work. Yeah, this looks like it. So let's just kill it. And suddenly my CPU drops from 22% to 10. I think that 10 is because I'm recording this. All right. So this is the kind of thing you can do with a runtime focused runtime. So the VM and the standard library and all of the tooling really allows you to get into things at runtime and investigate. If there's a memory leak, like we have this memory chart right here, you can just see what is using the most memory. Currently, that's the group server, but it's not, that's nothing weird. So there's a bunch of stuff running already, and this is part of how the Erlang runtime operates. Part of it is also development tools. All right, so that's processes. We spawned a ton of processes, and I think the default limit is around 1 million processes. Oh, Magnus asked, could you repeat how Erlang and Elixir relate to one another, and how do they differ? So how do they differ? That's a tricky one. But Elixir builds on top of the Erlang VM. So they compile to the same bytecode, and they run on the same virtual machine, much like all of the different things you can run on the JVM for Java related languages and the Java ecosystem. So they compile to the same language. They can use code from one another to some extent. And how they differ, I would say, that's what I covered earlier. So you'll have to get the previous video when that goes up, I think. But let's actually look at the higher abstraction of actor that comes with Erlang and Elixir, which is the gen server. So we have this, I call it the count actor. We can start it by calling start link, which is the convention. And we can pass it an interval. So let's start this up. We can use all our cores again. It's more fun that way. So we start link, we give it 1000 millisecond as an interval. And without getting into the nitty-gritty of the implementation, let's just say this will send, it will store the PID, process ID, of the process that's calling, so our IEX prompt, and it will start sending us a message. All right, I need to keep that PID, so let's do this. It's just a pattern match on the previous line. So we have the PID found. Okay, and since this prompt, this IEX shell is a process, there's a command to flush out and look at the process mailbox. These are the messages we've received so far since we started the count actor. Okay, flush it again. We've received further messages. So it sends us a message every second. Neat. Does it do anything else? Well, we implemented the oops function. And passing the PID to that, we can see the implementation of the oops function is unfortunate because this is dividing 5 by 0. And if you know your division, division by 0 is not usually a good thing. So we run that and we can see that it had an error, arithmetic error, bad argument in an arithmetic expression, and it crashed, because crashing is a big part of how you build resilient systems. Let's not get into it too deep, but because we had linked it to our shell also crashed and something restarted our shell. That would be a supervisor typically that restarts something that crashed, in this case our shell. You can see that our shell crashed because, well, shell process exited with reason, blah 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 blah, but also the IEX here goes from 7 to 1 and it restarted. So let's try supervision. So I've set up a module called supervised, which just creates one of the default supervisors with the strategy 1-for-1 for our count actor. So we can do start supervised 1000 and we can give it a name, foo. Now we're getting counts again because we started another count actor. So let's oops it. Let's do count actor dot oops, but pass it this name we gave it. So now we got the bad argument in arithmetic expression again, but we can see that our shell didn't crash. So what happens with messages? Well, they kept counting up until we crashed it over here. Then it restarted. This is the very primitive foundation of how to build resilience into your system. You have supervisors that restart your actors to a known good state when that's the useful thing to do. There are more strategies. There are a ton of details to unpack if you want to build really resilient systems. But this is a foundational part of it, and in very brief order. So now we keep getting these. So I think it's about time we do some web stuff. So let's start this with, so this is a Phoenix project. So I included the Phoenix framework. So let's look at our router. This is typical web framework stuff. You have a router, you have some paths. And we can start with that processes one. So let's go to localhost 4000 processes. And we can see that it shows some familiar stats. So this just takes some params, so we can't actually pass it a custom amount of processes to run. So we do count equals 5 instead, and that's a very low count. And then it runs that. But it does good process, spawn bunch, takes the result, and JSON encodes it, passes it to the client. So this would be the basics of building an API, but at a very rough and ready type of way to do it. We also have set up a channel. Now, this one is a little bit more complex because channels don't provide something you can look at by themselves. So I had to implement some JavaScript just to make it do something. So we'll see here in the console where we're receiving these messages. We join the counter. This channel is a process and it starts a count actor. We receive those counts and we broadcast them over the socket, which means that our client can receive them. So this is a very nice way of doing WebSockets. We've also implemented oops. So let's see, it's counter.oops. And we get an undefined return because it crashed, because that's what oops does. So we can see that this crashed, and actually we didn't supervise this, but the JavaScript library just retried the connection. So now connected again and receiving new counts. So that's channels. And channels is very nice if you're building a mobile app or you already have a front-end team doing React or something like that, or if you're doing offline first, where live view will not do. But let's look at live view. So we have this page live. We also have a template that we can look at. But we can shut that one down, get some more space here. So if we're connected, we start the supervised counter, call it foo. We assign some initial values to our socket. So this is where we keep all our state as assigns on the socket. We implement the capability of handling an event called oops and an event called run processes. These do familiar things. We send the oops, we spawn the good processes bunch. It can also handle receiving a count, which it will assign to the socket. It will also log with IO puts. So let's look at live view. So this is a very basic live view. We have a form here where we can do this. And if we run processes, we get the stats down here. We have the counter going since we started. And you can see it's essentially instantaneous. We can crash the counter, but since we started supervised, it just restarts, keeps counting. So what does the markup for this actually look like? Because that could be any level of complex, right? But if we're taking a look at it, I believe that's the one. It's just a section with a form and a Phoenix submit hook for the run processes event. We have an input field for that uses the num to get an initial value. And when we hit submit, it will temporarily disable while waiting for the result. And there's a second form for the crash button. And there's this, the results, which is, it always prints the count based on the assigned count. And it's a for loop, iterating through the stats, key and value, printing out the key and value. That's it. There's no more interactivity in this template, but it allows us to do, like backing it with this actor, because this is an actor. It starts, it keeps some state, it communicates with messages. The events are messages sent to and from the UI or received from the UI. And this is information coming from the inner parts of the system out to this actor. And there's a ton of interesting additional stuff you can do here. So that is live view. And this is a very, very simple demo of what live view can do. Now, I really, really enjoy working with this ecosystem because it is so deeply pragmatic. It is meant to build things in. I find it no nonsense, super productive, and incredibly easy to reason about. And that's where the functional programming makes me quite happy. It constrains how much state and many abstractions you actually need to keep in your mind at a single time. Because the functions typically just deal with the input and the output, and any module is sort of constrained to itself. And dealing with concurrency is just, okay, but this process can only do one thing at a time, but we can have many of them. So yeah, Elixir is what has made me come around on functional programming. And it's this particular flavor of functional programming I want and like. I still don't know lambda calculus. I still don't get it. But yeah, in this case, functional programming really helps me get things done and helps me do them well, build high quality, resilient, performant systems. And I think it does it in a way that essentially very few runtimes can without enormous investment. But someone started that investment back in the 80s with Erlang, so we can live off of that. So that's what I have to show today. If you have questions or anything, I'm happy to answer. And thank you for listening.
Thank you so much, Lars. I see we have a bit of discussions in the chat, but as Lars said, if you have any questions, please give them to him. Do we have anything?
So just wondering here, I as I mentioned in the chat, I've used Erlang before, a huge fan. But I've struggled a bit to get into Elixir, especially with web stuff. Last I checked out, Phoenix Framework was not a thing. Do you have any good resources that you guys use internally to onboard new developers or something that you could recommend?
So I'm a very, very small shop, so I don't have a lot of internally at all. I'll ask my wife, but no, she doesn't do Elixir. So, but actually the guides for the Phoenix framework are a good start. And there are good guides for setting up live view. There are good guides for working with channels. And I mean, any web stuff has a lot of complexity to it. So if you don't know web, you will always struggle getting started because there's just a lot there. But from looking at different web frameworks, I think Phoenix is very approachable in that way, and it strives to be. And for Elixir itself, there's a lot of resources like Elixir School, and Elixir comes with its own guide. The docs are very good. So like speaking to the developer tooling story of Elixir, all Elixir libraries essentially use Hex, which is the NPM of Elixir, I guess. So if we go to HexPM and just look for, let's go for Phoenix. So this is essentially looking at NPM, and if you look for the documentation, this is what you're dealing with. So it's nice, fresh, and modern.
It looks quite nice.
Yeah, and any library you pick up will have the same doc, the same kind of docs. It's pretty neat, and you typically write them by writing module docs straight in your modules. So.
Okay, well, that's nice. I guess I'll have to check out Phoenix. No.
Yeah, I really recommend it. I know there are efforts in Erlang to have a stronger sort of foundational web framework. I think Nova is probably one of the more recent efforts. I haven't tried it though. And Phoenix is really pushing forward at an impressive pace. So I definitely recommend checking it out. And I think if you don't love JavaScript tooling, LiveView is fantastic.
Yeah, that's the largest appeal. Plus the Beam, of course, which is a really well-designed piece of engineering.
Yeah.
Do we have any more questions or thoughts or want to discuss something? I can mention that we're going to send an email this afternoon with contacts for Lars and also Lars' webpage. So if you want to ask him questions or read more later, it's possible. Oh, one question here.
That's a good question. Yeah, and for contacting me, I think I'm on Twitter. It's Lawik, so Lawik, and you can reach me via my website underjord.io. You could sign up for my newsletter is what I'd recommend, because that's where you get most of my thoughts. But you can also just reach out via email. I'm happy to discuss Elixir. Okay, so how does the market look for Elixir developers? We need more of them. I'm talking like, if you knew Elixir to an intermediate level, I could put you in touch with at least like 4 companies I've spoken to recently that are looking for more developers. It's like the market overall is absolutely blazing hot right now, regardless of language, I think. So like Elixir is a little bit niche, but there's no lack of work to be done there. There's a lot of movement in the Elixir space, and I think Elixir came in at number 3 of the most well-compensated developers according to Stack Overflow. So it is a bit of a sort of senior developer playground for now, and we're trying to get more intermediate and inexperienced developers to get going with Elixir. But if you have sort of senior level experience and just pick up Elixir, you'll be in a good spot for working with a fun language, getting paid well, and having nice, interesting challenges. So yeah, the market looks pretty good from my perspective. Some, like, if you really want to work on site, I have no idea. I have no idea how that market is. I'm remote and I'll stay that way, thank you. But of course that constrains your search a bit if you want to be in your current town, especially in Sweden. But I know there are a few Elixir companies in Gothenburg, so I bet there are a bunch in Stockholm as well. Yeah, a lot of startups in US and Europe. So if you want to do Elixir in Phoenix, there's plenty of work out there. And if you know Elixir and are having trouble getting in touch with companies, I'm happy to sort of help out. Just reach out. I'll see what I can do. I can't promise anything, but I've definitely put people at work with Elixir. I just spun up a team of 4 people doing Elixir for a client of mine. So the market is good. One of my co-hosts just mentioned that he is having a lot of pressure on his courses. So he runs a Groxio, grox.io, teaching Elixir and other things. And he's an old Java developer, Java, Ruby, and then Elixir. And he's apparently training a lot of Java engineers to transition to Elixir, which I thought was interesting. And I know there are a lot of people wanting to apply Elixir in the sort of enterprise-ier space because it is quite powerful. I see a lot of fintech companies, a lot of blockchain companies picking it up. I'm not a super fan of blockchain, but it's definitely moving in that space.
Oh, I see. We still have some like discussions in the maybe it's a question in the chat.
Yeah. So yeah, Discord definitely have posted about implementing certain features or certain data structures in Rust as a highly performant particular case in their Elixir use. And there is a library that is intended to do just that. It's called Rustler, and it allows you to create these NIFs, native interface functions, or whatever, native implemented functions, I think, which is when you need to break out of the functional paradigm and do direct manipulation of data in that way, highly performant, like Discord is immense in scale, then you have that escape hatch. And I don't see it done a lot because it's less convenient, you have less guarantees, you can really screw up if you do a NIF badly, but it is an option you have. You also have other options where you can just call out to other programs and other programming languages in different ways. So you're not locked into the functional paradigm for performance sensitive work. There is also a project for doing machine learning in Elixir, without needing to write low level or mutable code, where they've implemented, so it's called NX. So if you're doing machine learning and you're curious about sort of doing that in Elixir, I'd check out NX. It's a super cool project, super ambitious, by Jose Valem. So it's a continuation of the Elixir work. All right, I think that's where we wrap up, right?
Yeah, thank you. Yeah, it's almost 1 o'clock, so I think that's it for today. And yeah, we will send Lars contacts afterwards if you get any questions later, or if you want to get in contact with Lars, maybe he can help you find assignments or anything else.
Yeah, don't hesitate to reach out.
Perfect.
It's what I do.
Okay.
Talk to people about Elixir if I can.
That's great. That's great. We appreciate it. Thank you so much for today.
Thank you.